So here is how we will integrate ln x using integration by parts. I'm going to consider this whole thing as a product of two pieces. I will consider this as u and that as dv. So as I try to integrate ln x dx, I would differentiate the u and integrate the dv. We have let the u be ln x and dv be dx. The derivative of ln x would then be 1 over x dx. And for the second part, as I try to integrate the left-hand side, as I try to integrate this, it will be the same as integrating the right-hand side, giving us b equals x. Once we have these four things in the box, we can rewrite this into u times v minus the integration of v times du. And all of a sudden, you will end up with something really nice. It will simply be 1 dx. So that's how we will integrate ln x using integration by parts. So for the next one, if I want to integrate e to the 2x times x squared dx, similar to what we did in the previous questions, I'm going to let u be one part and dv be the rest. I'm going to let u be something that can be differentiated easily. And I will let du be something that can be integrated easily. And I will choose dv so that as I integrate it, it wouldn't make my expressions more difficult. There are two parts for now, e to the 2x and x squared. Which one will be easier to differentiate? E to the 2o. Aren't they pretty much the same? It doesn't matter. We know how to differentiate both of them. No? You don't know how to differentiate both of them? E to the 2x. E to the 2x, differentiate it, give us this. And x squared, when you differentiate it, that gives us 2x. We know how to differentiate both of them. Well, of course, one of them looks more complicated than the other. But what about the dv? Which one will be easier to integrate without giving us more complication? Would you rather integrate this or that? If you want to integrate x squared, what would it turn into? Do you end up getting a higher degree polynomial or a lower degree polynomial? Higher degree. We don't like that. We want to integrate something that wouldn't increase the degree of your integral. Would it be a problem with e to the 2x? Can you integrate this and have it stay pretty much similar? Yeah, integrating e to the 2x will still give us e to the 2x, possibly with a constant in front of it, but it will still be better than having a higher degree for your square. So when we try to integrate expressions like this. I will let u be something that will lower the degree of your expression. And I would try to integrate something that wouldn't give us a hard time. Now du equals 2x dx. And as we integrate the dv, we will integrate that, giving us 1/2 e to the 2x. So as I proceed with the integration by parts, we will end up with u times v minus the integral of v du. And now you can simplify the expressions to something like this. Compared to what we were starting with, we have turned the x squared into x, making it a little bit easier to deal with. Can we integrate this now? Or do we need to proceed with another by parts? We still cannot integrate this by substitution. But I can use another by parts to integrate this. I'll let u be x again, and dv equals e to the 2x dx. And differentiating this will give us dx. Integrating this will give us another 1/2 of e2x. That means we will now be using another by parts to get this done. It will be u times v minus the integral of v du. V du. We have no trouble integrating that last part in this equation. It will still be e to the 2x. And this time you will end up getting 1/4.